Hi, good afternoon.
Hi.
Hi. Hi. All right, we're going to continue from yesterday. Yes, like yesterday, we are going to be drawing. And today it's really important that you try to make sure that it's a protractor today because we're going to be measuring some angles. So please take a look around, find yourself a handy-dandy protractor, and share with those next to you if for some reason we don't have quite enough to go around today. You don't need a new title, you don't need a new objective because this is a continuation. If you already started writing, that's okay. You also do not need to skip a page for KWL. This is all the same lesson. All right, here we go. Item the first is a recall. What does bisector mean? Yeah, middle, splitting it in half, splitting it in the middle. So if you're struggling to remember, you can go back to your notes or to my recorded lectures. Whoops, this is a B. To these sections, and that should give you that information. But what you're looking for on a bisector is something that's going to cut something else into two equal pieces, two congruent pieces. That recall sets us up for our first vocab for the day. The angle bisector of a triangle. The angle bisector of a triangle is a segment that is the angle bisector of a vertex of a triangle. I suppose let's write it all together in one word, of a triangle's vertex. Make it a little easier. I have left some space on the right hand side so that I can draw my figure. So just like yesterday, we're going to draw our diagram. Start with a triangle, and now you're going to draw angle bisectors. Okay? And try to draw this triangle here without getting in your way of the writing, because I know some of you are still copying the words. Oh, I failed at staying out of the way. All right, there's my triangle. Yep, there's the triangle. I have two ways to do this. I can use a compass. Here's my compass. Any triangle you love? Your favorite kind? You can use a compass and the construction of angle bisector techniques from, I think from this section, to physically construct the angle bisector. Or you can go with the I'm feeling lazy and don't want to construct method and take your protractor and measure a vertex of the triangle. So here I go. I'm going to go with the lazy man method. Now my triangle sides aren't quite long enough to reach, so I'm going to borrow someone's eligibility card here. Don't worry, I've turned it upside down. We won't read your names. And I'm going to line that up with the other side of my triangle. And now I can just read along the card. So looks like a 0, 10, 20, 30, 40, 5, 46. Let's call it 46 degrees. And then we make our marking at 23. Okay, it goes off the paper here, so I'm going to guess on this side. This mark is 25, so 23 is here. That's the angle for me. You'll have to make sure that you measure your own angle, take the full measurement, divide it by 2, and mark that, because that's the halfway part. We are measuring the angle at one of the vertices of our triangle, just like we would measure a normal angle. Yep, you pick your vertex. Find the measure, take that number and divide it by 2. Mark where that is, and that mark then will allow me to connect it to the vertex and construct my angle bisector. The important thing to note about this angle bisector is that these two angles are going to end up being congruent to each other. That's the definition. Okay? All right, this leads me to the very first theorem of the day. Do I have another what? Journal that you can look off of, yes. Will you pass this backwards, please? Thank you. Our first theorem for the day is very creatively called the angle bisector theorem. And it says this. Sorry. If a point is on the bisector of an angle, then it, the point we're talking about, is equidistant to the sides of the angle. All right, so go ahead and draw yourself any angle you want in the space that you left yourself. I'm going to try to do this again without interrupting your viewing of what I wrote there. I'm going to go ahead and draw my angle this way. All my other angles today have been like sideways opening angles. I want a downward opening angle because, I don't know. Okay, once again, you have a choice of using either your angle construction techniques or being lazy like me and just measuring your angle. Dividing that measurement by 2 and marking that new measurement. Okay, that's what I'm going to do. I'm feeling lazy. So here I am lining up my vertex. Okay, my vertex is in my vertex finder. I'm going to move my protractor around until the side of my angle lines up with my 0. Wow, and this one ended up perfectly 70 degrees. Yeah, I don't know how I managed that one. And half of 70 is 35. So I'm going to put a little mark there at my 35. And now if I connect this point I made to the vertex of my angle, I will have drawn my angle bisector. Again, the important part about this is that these two angles are congruent. Now what this theorem says is if we have a point somewhere on this line, and you can pick any point you want, I'm going to pick that one, that its distance from the sides of my angle are going to be equal to each other. Okay? But there's something that we need to take into consideration. Okay? Don't draw these next lines you're about to see, so just watch up here so that you can see where they are. If I look at the line that goes from, say, this point to here, and maybe this point this way, those are totally not the same length line. They're not. Okay? So what we need to keep in consideration is that what we need to have in order to have a shortest distance is we need to have some sort of perpendicular happening. I'm going to use the symbol for perpendicular because it takes up less room. So just like we used a technique to draw perpendicular lines when we were doing the perpendicular bisectors yesterday, and we were doing the altitudes yesterday, we're going to do the same thing, but we're going to use this point, and we're going to drop a perpendicular line from this point to each side of my angle. And that will represent our shortest, our most optimal distance. So what I'm going to do is I'm going to put my pen on the point that I'm worried about. I'm going to smack my protractor up against it. And then you see my little cheat 90-degree mark right here? I'm going to line that up with the side of the angle that I'm working with, that I want a line parallel to. There it is. And I'm just going to trace the edge of my protractor, and that will make this angle 90 degrees. Repeat for the other side. Because we want the shortest distance, the optimal distance between this point and this line. And in order to get that optimum distance, that best distance, that shortest distance, we have to have perpendicular things happening. Yes?
Where did you get
The point? You put it anywhere you want. It doesn't matter where that point is, as long as it's on the angle bisector. This point right here? Anywhere you want on the angle bisector. You get to make it up. You go, I like this point, and you put a point there. And that's the point you're using. Okay? Because our theorem just says if a point, doesn't say a specific one, just one of them. And there's lots to choose from, so you get to choose. Okay? I'm going to use the same technique to draw another perpendicular line over here against this other angle. Oh, I've run out of space there. Here we go. I'm trying to get that 90-degree little line there, guideline. I'm right there. There. It lined up. Okay, so the theorem says that if I did all this right, lots of ifs here, that those two segments that are in blue on your notes are supposed to be the same length. You can confirm this a couple of different ways. Take your protractors, little ruler thing, measure them, and they should be the same length. Or take your compass and set the compass radius to one segment, and then, just like we were doing the congruent segments kind of early in the year, without changing that radius, you see if it matches up to the other segment. I drew it right, it does. Had one class where it didn't match up. I mismeasured something. I felt really bad. Okay? So just give it a quick measure, whether you're using your compass or your protractor ruler thing. Yes, ma'am?
What happened to your hair?
The wind. I made the mistake of walking outside to go to a meeting, and this. I wish it had face cam. It's weird. I know. I have.
So I didn't know if you had it like bobby pin or something.
I do. I have a bobby pin here to try to keep it out of my face, and now it's sticking straight up. I give up. I don't know. All right. We only have 2 more items to cover today. Here is the next new word. It is the incenter of a triangle. The incenter. We just gave you a special segment, and now we're going to give you a special point. Can you guess which segment this one's related to? You'll see once we finish the definition. The incenter is the point of concurrency of the angle bisectors of a triangle. I'm going to take up this space right here to draw a triangle. So you get an extra chance. Draw a triangle. Draw 3 angle bisectors, 1 at each vertex. And they should all meet at some point somewhere, hopefully in the middle of your triangle. And they should all meet at one point, all 3 lines. And that's going to be your incenter. So go ahead and draw it now. I'm going to wait a few moments because I know some people are still copying this. Can I draw this real quick? All right, here I go. Gonna draw my triangle. I'm gonna try to draw an obtuse triangle. Don't know if this is gonna work out well, but. Okay, there's my triangle. Okay. Gonna measure my angles here. Alright, this looks like it's 39. I'm going to use this to draw straight lines with. Okay, 39. Half of 39 is 15, and 2 more. So 17. Yeah, so here. I'm guessing because I can't really see I have tape on my protractor. And I don't need to get it all the way to my guiding mark, especially if your guiding mark is in the middle of other text you've written. You don't have to have your lines go that far. Just get them to cross the other side of the triangle. I'm going to repeat my technique here to every vertex. I'll scoot this down so you can see here what I'm up to. Thank you, eligibility cards, for coming to the rescue.
Does it matter what you measure it with?
Preferably with a protractor.
Well, like,
We haven't done anything with links yet. These are all degrees. So you have to measure it with this part here. Maybe I'm not understanding the question.
I don't know. Oh my god.
Okay.
Yvonne, please.
Thank you. Okay, this one looks like it's 82, so 41. 41 is here. Again, I'm just taking the angle measures, dividing them by 2. Okay, I'm certainly not going to make that line all the way into there. I'm just writing, so I'm just going to stop when I cross the side. Okay, that's far enough. Okay, now I have my third line. I know they're supposed to cross in the middle, so I'm totally going to cheat, and I'm not even going to measure that angle. I'm just going to... No one saw anything. Okay? And there's my in-center. Right here. Here's my in-center. This definition of in-center is going to lead me to the final theorem of the day and the final theorem of this section. This theorem is very surprisingly called the in-center theorem. I hope that was intentional because it was awesome timing. All right, here we go. Gonna write it again. Again, I'm gonna keep my text small so that we can do one more diagram. All right, the in-center theorem says the in-center of a triangle is equidistant to the sides of the triangle. So you get another chance to draw another triangle, to draw more angle bisectors, to draw another in-center. So go ahead and draw that diagram now. Yeah, doesn't matter what triangle, doesn't matter what size. I would recommend that you try on a different triangle this time, you know. So if you've been drawing nothing but acute triangles, give some right triangles some love, you know. They're triangles too. Maybe put an obtuse triangle. I'm going to use an eligibility card to show you that you don't just have to use protractors. There's my triangle. Now go ahead. Do your angle bisectors. Yeah. And I'm going to go ahead and use a compass just in case those of you who want to see the angle bisector technique can see it hard at work. Okay. You can review how to do that by rewatching the videos that are linked, the lectures that are linked in the videos from above. Whoops. You guys kind of remember doing this if you're wanting to. Yeah. I'm just going to get and mark all 3 of them real quick while I have the tool out. I'm not even changing the radius each time. I'm just going for it. Was putting the marks for angle bisector. So go back and rewatch that lesson. So here are points. Oh goodness. This one and this one. Okay, so this one goes to this one. Oh, that's promising. Look, that one goes. Oh, that's good news right there. Yours was perfect? Good job. Mine isn't. Oh, it did. All right, mine was perfect. I just didn't think
the
this.
same one as the top one?
Yeah, it's going to be this. We're doing in-center again because this is the in-center theorem. Okay. Now, here's what the in-center theorem says. Oh, people are still drawing? Oh, wait. Are we done drawing?
Set it to like
For the arcs and things?
Yeah.
Anything you want. And on this particular triangle, I ended up just keeping them all exactly the same. Yeah. I didn't feel like messing with it. All right. So the theorem says this. This point right here, which is the in-center, is the same distance from every side, which means this part of my segment right here that goes from the in-center to the side is going to be congruent to this segment right here, which is going to be congruent to this segment right here. All of these sides are going to have the same distance. Okay? Yeah? All right. Any questions about any of the items shown today? Questions about anything over the whole section? All right. Thank you very much.